Yeah, hi students. In this video, we're going to discuss about trigonometry, like a complete basics of trigonometry, like all the concepts and formulas. So whatever we need to do other questions from boards or Ncert or mains, we can just if you follow this class till end, definitely I think you'll get clarity about trigonometry. Nana. So now we have first measurement of an angle, like whenever you take as ray, like for example horizontal or something like this. Okay, and let us say this is the initial ray and the another one is the terminal ray. Then the amount of rotation of the initial to terminal position is called as angle, which is denoted by theta, which is always measured in anti-clockwise direction. Anti-clockwise direction. Okay, and if the angle is measured in clockwise direction, so anti-clockwise means this one. So if they measured in clockwise direction, then we always take it as minus theta. Okay, in how many ways we can measure the angle? That is the next thing that we are going to discuss. That is, first one is sexagesimal measurement, which is degree system, and next one circular measurement, which is radians. These two are very often to use. The next one is centesimal system, which is a great system. But of course, these two are very like often to use in the problems and like wherever you can see in the books and all, you can see these kind of these two systems only. Sexagesimal system means they where we will take one right angle is equals to one right angle is equals to 90 degrees we are going to take, and in circular system one right angle is equals to pi by 2 radians we are going to take. That means here one right angle in degrees is 90 degrees, and one right angle in radian measure is pi by 2 radians. And next, if you take grades, one right angle is equals to 100 grades we are going to take. So that means one in grade system we will take one grade is one right angle is equals to 100 grades. This is the relation between these three systems. So if you want to convert any angle, like for example radians to radian measurement, they given like some pi by 4 degrees, then we already know that pi is equals to 180 degrees, then 180 by 4 is 45 degrees. It's simple. But if the given degrees, some degrees is equals to some 135 degrees, then now we can convert into the radian measure. That's the reason we can use that relation. Now what is relation? We have d by 90 degrees is equals to the radian pi by 2, right? So in degrees place you substitute 135, so it's by 90, and that is into pi by 2, that is equals to r. It's just if you move to other side. Now what we get here in 5 table we can cancel, no? 45 table we can cancel. I think 45 2s and 45 3s are, then radians is equals to 3 pi by 4. So like this we can convert the degrees into radians and the radians into degrees. So this conversion is important. Of course, definitely while you are doing those questions, you can see some questions like 7 pi by 11, 11 pi by 11 pi by 14, something like this. Whatever it is, you can try to convert that into the degrees, or else you can keep it as it is if the conversion is not possible, because you may get some decimal values and all. Okay. The next thing you should know is the important points, the trigonometric ratios or trigonometric functions. To discuss trigonometric ratios, we always take one right angle triangle. So one right angle triangle A, B, C. The side opposite to angle is called as opposite side, and the side adjacent to angle is called as adjacent side, and the side opposite to right angle is called as hypotenuse. So here we have three sides. So by using three numbers, how many ratios we can form, Nana? Can form A by B, B by A, B by C, C by B, C by A by C. How many, Nana? Total 6 ratios we can form. So here also we can form 6 ratios: opposite by hypotenuse, adjacent by hypotenuse, opposite by adjacent side. So these are the three important trigonometric ratios which we can always remember, which is like opposite by hypotenuse, they given their name for it as sin theta, and adjacent by hypotenuse they given as cos theta, and opposite by adjacent they given as what, on a tan theta. And the reciprocals of the respective, the reciprocal of tan is cot theta, and the reciprocal of cos is known as secant theta, and the reciprocal of sine is known as cosec theta. So since they are reciprocal to each other, then definitely we can form a relation there. So sin theta into cosec theta is equals to 1, we can write. Now similarly we can write cos theta into secant theta is also equals to 1. Then tan theta into cot theta is also equals to 1. These are the three important relations that we can remember. Right, students? Okay, this is about the trigonometric ratios. Next, now here, this by using these trigonometric ratios, if you remember in grade 10, you just got like three trigonometric identities. So what are those identities? The first one is sin square theta plus cos square theta is equals to 1, right? So from this we can write sin square theta is equals to what, Nana? 1 minus cos square theta, and sin theta is equals to under root 1 minus cos square theta. Next, cos square theta is equals to 1 minus sin square theta, and cos theta is equals to what, Anna? Square root of 1 minus sin square theta. So we can write sin in terms of cos or cos in terms of sin by using this formula. And next identity we have is secant square theta minus tan square theta is equals to 1. So from this we can write secant square theta is equals to 1 plus tan square theta, right? Then we can write secant theta is equal to square root to other side will be square root of 1 plus tan square theta. And next, if you move 1 to other side, you will get secant square theta minus 1 is equals to what, on a tan square theta. Then tan theta is equals to under root of secant square theta minus 1. Now, if you look at this identity, it is like a square minus b square. That means we can write that as secant theta plus tan theta into secant theta minus tan theta, because we are using a square minus b square formula, which is a plus b into a minus b. Now from this I can write secant theta plus tan theta is equals to what, Nana? 1 by secant theta minus tan theta. Similarly, secant theta minus tan theta I can write as 1 by secant theta plus tan theta. Okay, so this is the other formula, secant theta minus tan theta and secant theta plus tan theta are the other identities. And of course, definitely we are going to use all these identities in the by solving the questions. And the next identity we have is cosec square theta minus cot square theta is equals to 1. So from this we can write cosec square theta is equals to 1 plus cot square theta, and cosec theta is equals to under root of 1 plus cot square theta, right? And move 1 to other side, it will be cosec square theta minus 1 is equals to cot square theta, and under root cosec square theta minus 1 is equals to cot theta. So got it. And now we can see that it is like a square minus b square formula again, just like the previous one. We can write this as cosec theta plus cot theta into cosec theta minus cot theta is equals to 1. Cosec theta plus cot theta is equals to 1 by cosec theta minus cot theta, just by moving this to other side. And similarly, cosec theta minus cot theta is equals to 1 by cosec theta plus cot theta. Okay, so this is how we can just write the formula from the trigonometric identities, right, students? Now, by using these identities, we'll try to solve few questions. You can see that sin theta plus sin square theta equals to 1 they given. That means from here we can write sin theta is equals to 1 minus sin square theta, which is sin theta is equals to cos square theta. Next here, and if you look at the coefficients of these terms, cos power 12, cos power 10, cos power 8, cos power 6, it's like 1 3 3 1. So which, if you know like a plus b whole cube formula, in that a plus b whole cube formula you can see these coefficients, right, students? That means, but it's not exactly looking like a plus b whole cube, but by taking like cos power 6 theta common, you can see that is the least term there. So we'll get cos power 6 theta here and 3 cos power 4 theta, and this is 3 cos square theta plus 1 minus 1, that is equals to 0. That is actually we have to prove. Okay, no need to write that then. So now cos power 6 theta can be written as cos square theta whole cube, right? And here you can see that It is like cos square whole cube and 3 cos square whole square and 3 cos square and 1 cube. It is like a plus b whole cube. That means cos square theta plus 1 whole cube we can write now. Right? Because you can see a plus b whole cube. What an a cube? We'll get cos power 6 theta. 3a square b. Anyway, b is 1. So 3a square will get this. 3ab square will get this. And 1 cube. So what is cos square and a sin theta? Here also sin theta I am substituting. And whole power cube, because that is what we have here. So now if you multiply sine inside, it is going to be sine square theta into 1. So sine theta whole cube minus 1. Now what is sine square theta plus sine theta? Now that is equals to 1. So 1 cube minus 1, that is equals to what? 0. Is equals to 0. So that is what they are asking us to prove. Okay, students. So next, prove that under root 1 minus cos theta by 1 plus cos theta is equals to something they given. So now here, so if you just simply what you can do, just do rationalization. So 1 minus cos theta by 1 plus cos theta, I can just simply multiply with 1 minus cos theta by 1 minus cos theta. So just multiply 1 minus cos into 1 minus cos, 1 minus cos whole square. So I can simply write 1 minus cos theta whole square is divided by under root a plus b into a minus b, which is a square minus b square. So 1 minus cos square will give you sin square. So square root get cancel, here also square root can get cancelled. We'll have 1 minus cos theta by what? Sin theta. So now 1 by sin is what? Cosec theta, and cos by sin is what? Cot theta. So this is what we have from the given question. Okay, this is how we can do it. Next, sine of trigonometric ratios. So discuss about sine of trigonometric ratios. So what I am doing is, I am taking a coordinate system, of course, which will divide the entire plane into 4 equal parts, and each part is called as quadrant. So quadrant 1, and this is quadrant 2, and this is quadrant 3, and this is quadrant 4. And the next we have this. So let us consider a unit circle, and here we have for example, if you take angle from here, so 0 degrees, then what? 90, next 180 degrees, 270 degrees, then 360 degrees, right? So if you go from the first quadrant, it will be 0 plus theta, right? That means plus theta. And next 90 and clockwise, so 90 minus theta, then 90 plus theta, and this is 180 minus theta. Next here it is 180 plus theta, 270 minus theta. So 270 plus theta, 360 minus theta. Of course, minus theta also will come like this if you take. Okay, so to discuss the sine of trigonometric ratios, what I will do is I'll just consider here a right angle triangle on this x-axis. Let us say this point is some x comma y. You can see that the x is positive and y is also positive, and since it is a circle, the radius is always positive. And in this right angle triangle, if you take all these three sides are positive, so therefore all the trigonometric ratios are positive. And next, if you take a right angle triangle with the same sides, then the right angle triangle look like this here. Then it is negative x and it is positive y and of positive y. You can see adjacent side, if you take angle here, adjacent side is negative. That means the sides which are not depending on adjacent sides are going to be positive. So what sides will not depend on adjacent side? Nana, you can see sine and cosec. So only sine and cosec are positive in this right angle triangle. Because if you write tan, what you write on opposite by adjacent? So y by minus x. So negative, right, students? If you write any other, like if you write cos or tan or cot or secant, all of will be negative. Okay, next if you take right angle triangle in third quadrant, you can see it's negative x and negative y also, because third quadrant, na? So negative x, negative y. If you look at the tan formula, opposite by adjacent, so both are negative, so positive. So tan is positive, so it's reciprocal also positive. So tan and cot are positive in the third quadrant. Why, Nana? Because opposite adjacent are having same sign, both are negative. And if you look at sine, cos, secant or cosecant, any one only we have, so it will be negative only because automatically, so yeah, the radius is always positive. And if you take right angle triangle in fourth quadrant, you can see x is positive and y will be negative. So opposite is negative. So the sides, the ratios which are not depending on its opposite side are positive. What ratios will not depend on opposite? Cos theta and secant. So therefore they are positive. So you can see that in this, from this figure, you can understand that in the first quadrant, all trigonometric ratios are positive. In the second quadrant, sine and cosec are positive. And in third quadrant, tan and cot are positive. In fourth quadrant, cos and secant are positive. Like this, we can discuss the signs of trigonometric ratios. Right? Of course, all silver teacups you may have, so that is a shortcut, Nana. So this is actually the reason to discuss about the side. This is actually the reason for those all silver teacups, like which quadrant which is positive and all. And one more thing here I just want to add is, if you take a right angle triangle on y-axis, you can see here, for example. So this, and the total angle is 90. So this is going to be what, Nana? I will draw it here. This angle is going to be what, Nana? 90 minus theta. So this is x. So therefore opposite also x, and this is y. Then opposite also y. So actually in the original triangle here, so the adjacent is x, but that adjacent is becoming opposite here. So adjacent becomes opposite. From opposite it becomes adjacent. That means what you can understand here, Nana? Simply you can see that when you are taking right angle triangle on y-axis, the sides are changing. It means adjacent is becoming opposite and opposite is becoming adjacent. That means for 90 plus or minus theta and 270 plus or minus theta, because the angle, the right angle triangle on y-axis I am taking. So sine becomes cos, cos becomes sine, tan becomes cot, cot becomes tan, secant becomes cosecant, and cosecant becomes secant. Sir, what about some 0 plus or minus theta, sir, or 180 plus or minus theta, 360 plus or minus theta? No, it is on y-axis only, sorry, x-axis only. So if it is x-axis, there is no change in the right angle triangle, right? So it will look as it is, same. Sine becomes sine only, tan becomes tan, cot becomes cot, secant becomes secant, cosecant becomes cosecant only. There is no change. So there is no change in these for these angles. Only for 90 and 270 it will change. Right. Sir, what is the use of this? Now, for example, you want to find out, let us say we are discussing about some sine 150 degrees. So since we already know from 0 to 90 degrees, that's why I didn't discuss those values, Nana. So directly I'm just discussing sine 150. So 150 can be written as what, Nana? 180 minus 30. So 180 minus 30, which is in second quadrant. So sine is positive. For 180 there is no change, sine only you will get, so sine 30. This is how we can write. So sine 30 value is what, Nana? 1 by 2. So everything will be converted in the angle between 0 to 90 only, because those are the values we know. So try to convert the whatever the big value they given, big angle they given, convert in terms of 0 to 90, and you give the value for it. To convert that into 0 to 90 only, we have got signs of trigonometric ratios in different quadrants. Sir, how we will find then cos 225 degrees? Cos 220. 225, so the nearest angle we have to take on x-axis or y-axis. Okay, whatever the angle it is. On x-axis or y-axis you can take. So 225 can be written as what, 180 plus, sorry, 180 plus 45 degrees. 180 plus 45. So 180 plus theta, third quadrant. In third quadrant, cos is negative. See, cos is negative, and for 180 cos becomes cos only, so cos 45. So it's minus 1 by root, like this. Or let us discuss some cosecant 300 degrees. Cosecant 300 degrees. So this can be written as 300 means I can write as 270 plus 30. Or you can write 360 minus 30 also. That is also fine now. Okay, so cosec 270 plus 30. 270 plus theta means what now? Which quadrant? Fourth quadrant. In fourth quadrant, cosec is negative. So for 270, cosec becomes what, Nana? Secant, because it will be on y-axis. So secant 30. So what is secant 30, Nana? 2 by root 3. So minus 2 by root 3 is the answer. Okay, sir, till 360 it is fine. We can take the angle with respect to the coordinates or not. But what about if the angle is given more than 360? Let us say, for example, they are discussing about cot 600 degrees. Cot 600. So if they given more than 600, first see one complete cycle. So we know that one complete cycle is 360, and the next complete cycle will be 720. The next will be 1000. Like this we can take now. So 600 in second cycle. So 360. So here it is 360. Then next we have 450 plus 90. Then it is plus 90, 540 plus 90, 630. So we can write 630 minus theta, which is nothing but 270 minus theta. Anything is fine. Because cot 600 will be same as cot 240, because 360 plus 240. Apart from 360, the additional thing that you are taking is 240. That I can write. So which is nothing but 270 minus 30. 270 minus theta, third quadrant. In third quadrant, cot is positive. So for 270, cot will be changed to tan 30, which is going to be 1 by root 3. Like this, whatever the angle they given, we can convert, we can do it. Sometimes they will give it in pi nano. Let us say they are giving like some secant 11 pi by 3. Secant 11 pi by 3. If you wish, if you want to convert into angles also, you convert, because pi by 3 is what, Nana? 60. So it is going to be 660 degrees. You can write like that. Your wish, however you want. So just now we discussed, like for 360 it is more than like plus 300 degrees. So I can rewrite this as what, Nana? Secant 300 degrees. Then you can solve like this. Whatever it is, you just try to convert whatever the angles you know. In that way you convert. For example, from 0 to 360, it's easy to find. So whatever the big value they given, just take how many cycles they given and convert into 0 to 360 only. And after converting into 0 to 360, then what we are doing, we are trying to convert that angle into then again 0 to 90 degrees, because those are values you know perfectly. So to convert that only, we have like those trigonometric signs of trigonometric ratios now. So from that we can do that. Right, students? Okay. Look at this question. So cos x they given. Cos x is equals to what, Nana? Minus 3 by 5 they given. X lies in the third quadrant they mentioned. X lies in the third quadrant. Okay, so cos means what, Nana? Adjacent by hypotenuse. So 3, 5 means by the Pythagorean trigonometry, it is going to be 4. Now you write normally all the trigonometric ratios value. So sine you write which is opposite by adjacent, hypotenuse, and tan you write which is opposite by adjacent, and cot you write which is reciprocal of that, and secant you write which is reciprocal of cos, so 5 by 3, and cosecant you write which is reciprocal of sine, which is 5 by 4. Okay, which is 5 by 4. Now you can see that. So it lies in third quadrant. In third quadrant, sine is negative, tan and cot are positive, and secant cosecant also negative. So these are the values. Right, students? Okay. Now what about this? Cos 10, cos 20, cos 30, and so on, plus cos 180. Hmm? Okay. So they given like cos 10, cos 20, and so on, cos 80 only they given, till cos 80. So cos 170 can be written as what, Nana? 180 minus 10. 180 minus theta is what, Nana? Cos of 180 minus theta. 180 minus theta lies in second quadrant, so cos is negative. So for 180 will be same. So minus cos 10. So this is minus cos 20, and this is minus cos 30. Okay, and this is minus cos 80. So you can see, of course, there is a typo. I think there is nothing with this, and so on. So these are the values they given. So minus cos 80 plus cos 80. minus cos 30 plus cos 30 minus cos 20 plus cos 20 minus cos 10 plus cos 10, right? So all those values cancel. So what is the answer now? 0. Simple, right? Next, trigonometric ratios of compound angles. To discuss the compound angles, first of all, what is compound angle? The compound angle is nothing but the algebraic sum of one or like two or more angles, so like a plus b or a minus b or a plus b plus c or a plus b minus c and so on. Okay, now here to discuss the compound angle, I mean trigonometric ratios of compound angle means what? An sine of a plus b or cos of a plus b, something like this. So now what I will do is I'll try to take a rough figure, for example something like this. Let us consider one right angle triangle with angle A, and on this hypotenuse I will consider one more right angle triangle something like this with the angle B. Now if I draw one perpendicular from this vertex to the horizontal line, okay, now you can see the angles here. So let us give the names for these vertices O, P, Q, R, and if I draw one horizontal line here, this also will give you a right angle triangle, so S and then T, and this is capital A, and this is going to be 90 minus A, and you can see that. So then by using this triangle property I can say that it is capital A again, right? Now for example I will discuss cos of A plus B, for example, from this figure. So where is A plus B? In the triangle RTO. In the triangle RTO you can see that A plus B. So what is the cos formula? Adjacent by what? No, hypotenuse. So OT by OR. So that OT I will write as OP minus TP by OR. So OP by OR, and in place of TP I can write SQ. So SQ by OR. Right. So OP and OR, there is no common right angle triangle, but if you have a OQ in between them, then you can see you have a common right angle triangle. So what I will do is I will multiply and divide with OQ. Similarly, SQ and OR, we have a common side which is RQ. So I will multiply and divide with RQ. Right? Okay. Now we can see that, so therefore cos of A plus B is equals to OP by OQ is nothing but cos A from the first triangle, and OQ by OR is cos B from the second triangle, minus SQ by RQ from this small triangle. If you can see, SQ by RQ is sin A, into RQ by OR is also what? Sin B. So what is the formula we got for cos of A plus B? Cos A cos B minus sin A sin B. And if you replace that B with minus B, minus theta lies in fourth quadrant. So cos A is positive only. So directly we can write cos A cos B. But in place of B, if you write minus B here, sin of minus theta is negative sin theta, because it's fourth quadrant, sin is negative. So it becomes minus into minus plus sin A sin B. This is the formula for cos of A minus B. Similarly, we can write the formula for sin of A plus B also, because since you have cos of A plus B is equals to what? You have the formula like cos A cos B, right, minus sin A sin B you have. So this cos of A plus B I can write as, what I will do is, just a second. Now to get the sin of A plus B, so what I will do is, I can write sin theta as cos of 90 minus theta, right students? That means it is going to be cos of 90 minus A minus B. So this I will take it as A. So, and this is B. So cos of a minus b. So what is cos of a minus b formula, Nana? Cos a cos b plus sin a sin b. So cos of 90 minus theta is sin theta into, so therefore sin a cos b, and sin of 90 minus theta is cos theta, so cos a sin b. You can see that you have the formula for sin of a plus b here. So then what is sin of a minus b, sir? Just simply replace plus b with minus b. So sin a cos b, cos of minus theta is cos theta, but sin of minus theta is minus sin theta, so it becomes minus cos a sin, right? This is how we can write the sin of a minus b formula. Then what about addition of those? Like for example, you have cos of a plus b plus cos of a minus b. So what you will get if you add it? So cos of a plus b is here minus sin a sin b, and cos of a minus b will get plus sin a sin b. Both get cancelled. So what will get Nana here? 2 cos a cos b. And what about if you subtract? So cos of a plus b minus cos of a minus b. So what you will get if you subtract? If you subtract, then cos a cos b get cancelled, and this is minus sin b. Here also will get minus sin a sin b. So which is minus 2 sin a sin b. And if you want to write only minus 2 sin a sin b, then you can multiply minus. When this becomes plus and this becomes minus. So then what about sin of a plus b addition? So sin of a plus b plus sin of a minus b. Then what will you get? You have here sin of a plus b is this, sin of a minus b is this. Add this cos a sin b minus cos sin b get cancelled. So you have 2 sin a cos b. And if you have a sin of a plus b minus sin of a minus b, then what about this? So minus means these two get cancelled, then you will get 2 cos a sin b. Okay, next. So what about multiplication? So like for example, if you do cos of a plus b into cos of a minus b, you can see there is the only change is minus in between them. Okay, that means it will look like a plus b into a minus b. So a square minus b square. After simplification, what you will get is cos square a minus sin square b over r cos square b minus sin square a. Okay, so you can see in cos of a plus b and a minus b formulas, we are getting cos or plus or minus sin. And if you add also or if you subtract also, you are getting cos or sin, right? In cos of a plus b, cos of a minus b, and addition of those two. But if you multiplying, you are getting two different. I mean cos and sin, cos square a minus sin square b, or cos square b minus sin square b. And when you look at sin of a plus b and sin of a minus b formulas, you're getting like together, like sin cos cos sin cos cos sin. Even if you add, if you subtract also, you're getting sin cos cos sin. But if you multiply sin of a plus b into sin of a minus b, then you will get both sines or both cos. That is the difference. So try to understand that difference here. Sin square a minus cos square, sin square a minus sin square b, or cos square b minus cos square. Okay, next tan, compound angle sum. So tan of a plus b. So tan of a plus b can be written as what, Nana? Sin of a plus b by cos of a plus b, right? So sin of a plus b is what? Sin a cos b plus cos a sin b is totally divided by cos a cos b minus sin a sin b. Now what I will do is I will divide by cos a cos b. Just divide, cos get cancelled, and you will get tan a, and cos a cos get cancelled, you get sin b by cos b, which is tan b. And I am dividing with this, so it becomes 1 minus sin by cos is tan, and again tan. So this is the formula for tan of a plus b. Then what is the formula for tan of a minus b? So tan of a minus b is what, now just replace b with minus. Anyway, tan of minus theta, we know that it is minus tan theta. So tan a minus tan b by 1 plus tan a tan. And similarly, if you write for cot of a plus b, reverse na, because I can simply write cos by sin. So that you will get cot a cot b minus 1 by cot a plus cot b. Next, cot of a minus b, you will get cot a cot b plus 1 by cot b minus cot a. Okay, students. So this is how we can derive the formulas for trigonometric ratios of compound angles. If you try to understand that pattern in what way we discussed, so you can easily remember these formulas. Or like definitely those sine of a plus b plus sine of a minus b, or cos of a plus b plus cos of a minus b, and those product and all we are going to use in the formula in the questions like anything now. Okay, right now. So cot of a plus b, then you have, let us say, tan of a plus b formula, you have like tan a plus tan b by 1 minus tan a tan b. This is what you have, right? So for example, b is equals to 45, I will take. Then what I will get on here, tan of, so 45 plus a. So tan 45 value is what on a 1. That means this can be written as 1 plus tan a by 1 minus tan a. Further, if you write in place of tan, if you write sine by cos, then it will be cos a plus sine a, right, by taking LCM, and whole divided by cos, and again cos a minus sine a whole divided by cos, right? So whenever you see cos a plus sine a and cos a minus sine a, you can recall this formula. Similarly, if you write tan of pi by 4 minus a, by using the same thing, you can write cos a minus sine a by cos a plus sine a, students. Okay, like this we can write these formulas as well. Okay, right. Next, so next what we can write, just a second. Yeah, so look at this basic question. So sine alpha is equals to 3 by 5, that means cos alpha is equals to what on a 4 by 5 by using pi diagram triplet. Cos beta, so 9 and 41, this will be what on a, by using Pythagoras theorem, 41 square minus 9 square. 41 square is what, 1681, I think. So 1681 minus 6 minus 81, which is 1600. That means 40. So root 1600 is what on a 40, na? Root 1600 is 40. So sine beta is opposite by hypotenuse. That's it. Now what is the question? Sine of alpha minus beta. Just sine of a minus b. So sine a cos b minus cos a sine b. So sine alpha is 3 by 5 into cos beta is 9 by 41 minus cos alpha is 4 by 5 into sine beta is 40 by 41. You can see the LCM is same, so 205. So it's 27 minus 160, which is minus 133 by 205 is the value of sine of alpha minus beta. The simple basic question now, okay, to understand like the usage of the formula. Next, look at this. Tan A equals to K into tan B. How we can solve this? So you can see that here you have tan A by tan B is equals to K. I can write as K by. And here you should remember one thing: componendo and dividendo formula. What is this componendo and dividendo, sir? For example, if you have a by b is equals to some c by d, then numerator plus denominator by numerator minus denominator is equals to numerator. The same thing will apply here also in the RHS. Numerator plus denominator by numerator minus denominator. Or else reverse also. Numerator minus denominator by numerator plus denominator. denominator by is equals to numerator minus denominator by numerator plus denominator. Anyway, we can, this definitely will works for all the values, all the real numbers. Okay, whatever, for example, check, we know that 1 by 2 is equals to 2 by 4. Check it, this formula definitely will satisfy. So this is called as componendo and dividend. Sir, how you are getting this idea, sir? No, the moment you see this k plus 1 by k minus 1, definitely you can see that. No? So apply componendo and dividendo formula here. So I can write numerator plus denominator is divided by numerator minus denominator, that is equals to k plus 1 k minus 1. Whatever the rule you apply, whatever the pattern you apply, going to apply for LHS, the same thing you have to apply for RHS also. Now tan A is what? Sin A by cos A, and tan B is what, nana? Sin B by cos B by, again tan A is what, nana? Sin A by cos A, minus here it is sin B by cos B is equals to k plus 1 by k minus 1. Now if you take LCM in the numerator, it becomes sin A cos B plus cos A sin B whole divided by cos A cos B. Right, here also you will get sin A cos B minus sin B cos A whole divided by cos A cos B. So those two get cancelled, that is equals to k plus 1 by k minus 1. So the numerator is a sin of A plus B and denominator is what, Anna? Sin of A minus B. That is equals to k plus 1 by k minus 1. So sin of A plus B is equals to what you can write, Anna? K plus 1 by k minus 1 into sin of A minus B. So that is what they are asking us to prove. So one of the important formula on a component and dividend. To understand that only I given this example. Okay. Right, next. Look at this question. So what they given here, cos square 73 plus cos square 47 plus cos 73 cos 47 is equals to 3 by 4. Now here, so we don't have any formula for cos square A plus cos square B, but we have a formula for cos square A minus sin square B or cos square B minus sin square A. So I will try to write one of them in terms of sin. So cos square 73 plus cos square 47, cos square theta I will write as 1 minus sin square theta. And it's like cos A cos B. So I have the formula for 2 cos A cos B. So I will multiply and divide with 2. Okay, so it's 1 plus cos square A minus sin square B. What is the formula? Cos of A plus B into cos of A minus B. You should remember those formulas, and without reminding those formulas, we can't solve the questions. Right? Even if you don't know the formulas now, you can understand what I'm teaching here. You should know those formulas. Right? And here 2 cos A cos B. 2 cos A cos B formula is what, Anna? Cos of A plus B plus cos of A minus B. 1 plus cos 120 and cos 26 and 1 by 2 cos 120 plus cos 26. So what is cos 120 value, sir? See, we discussed about the signs of trigonometry ratios and also 120 can be written as what? 90 plus 30. Oh, sir, 180 minus 60. Of course, 180 minus 60. Both will give the same answer. Cos 90 plus theta. 90 plus theta lies in what, on a second quadrant. In second quadrant, cos is negative. So it's going to be negative, and for 90 it is going to change. So sin 30. So minus sin 30 value is what, on a 1 by 2. So minus 1. So 1 minus 1 by 2 into cos 26 plus 26. 1 by 2 into minus 1 by 2 is minus 1 by 4 plus 1 by 2 cos 26. So you can see these two get cancelled. 1 minus 1 by 4 is what, done? 3 by 4. So that is what they are asking us to prove. Is it clear, students? Right. Next. Look at this. Cos 20 plus sin 10 cos 20 plus sin 10 degrees divided by, so sin 10 I will change because we don't have any formula for cos A plus sin B or something like that, but we have the formula for cos of A plus B plus cos of A minus B, sin of A plus B plus sin of A minus B, those kind of. Convert one of them into either cos or sin, that is better, right? Sin theta, so sin theta can be written as cos of 90 minus theta. So sin 10, 90 minus 10 means what? On 80. This also cos 20 minus cos 80. Uh, we don't have this formula. Of course, we have the formulas in the next, maybe after 2-3 slides, we may get that formula. But now we know only cos of A plus B, cos of A minus B, sin of A plus B, sin of A minus B. That formulas only we know, right? So we have to write, take two numbers whose sum is 80 and difference is 20. Sum is 80 and difference is 20 means 50 plus 30 and 50 minus 30, right students? So we can write cos 50 minus 30 plus cos 50 plus 30 is totally divided by cos 50 minus 30 minus cos 50 plus 30, right? So cos 50, see it's like cos of A plus B plus cos of A minus B. What is the formula, Nana? 2 cos A cos B. Next, cos of A plus B minus cos of A minus B. What is the formula? Actually, if it is reverse, minus 2 sin A sin B. But it is like this now, so no need to write minus, directly 2 sin A sin B. So 2 to get cancelled. Cos 50 by sin 50, which is cot 50. Cos by sin, which is cot 30 is root 3. They are asking in terms of tan. So cot 50 is equals to what? Tan 40 only, because they are complementary angles, right? Because 90 minus 40 you can write now, this as 90 minus 40. Cot of 90 minus theta is what? Tan theta, right? Okay, so next, trigonometric ratios of multiple angles, and even here only we will discuss submultiple also. So we'll start with sine. So for example, we have sine of A plus B formula, Nana. What is sine of A plus B formula? Sin A cos B plus cos A sin B. So if I replace B with A, so what I will get here? Sin 2A. And here sin A cos A sin A. Both are same, which is 2 sin A cos A. Right? Sin 2A is 2 sin A cos A. Okay, fine. Now 2 sin A cos A divided by 1 I can write here. 1 is nothing but, for example, I will write cos square A plus sin square A. So now 2 sin A cos A, if I take cos square A common in the denominator, I will get 1 plus sin square A by cos square A, because there is no cos there. So 1 cos get cancelled, and you can see that what you will get here, which is 2 sin by cos, so tan A, by 1 plus sin square by cos square is what? Tan square A. This is how you can write the sin to A formula in terms of sin and cos, and in terms of only tan. Depends on the question, depends on the situation, we have to use any one formula. Since sin 2A is becoming A and A, you can see that formula. That means if I write the formula for sin A, then what I will get? Half of it, which is 2 sin A by 2 cos A by 2. And in terms of tan, you can write 2 tan A by 2 by 1 plus tan square A by 2. Right, students? Next, similarly cos 2A. What is the cos of A plus B formula? Cos A cos B minus sin A sin B. Replacing B with A. That means it becomes cos A into cos A minus sin A into sin A. So I can write simply cos square A minus sin square A. I will replace sin square with 1 minus cos square. Then what I will get? Minus of minus cos square plus cos square, and cos becomes 2 cos square A minus. Or I will replace cos square with 1 minus sin square. And what I will get? 1 minus sin square, which is 1 minus 2 sin square. Same like the previous one, I will divide with cos square A plus sin square A. which is 1. Take cos square common. Then it becomes, in the numerator it becomes 1 minus sine square by cos square, which is tan square. Denominator will be same. So 1 plus tan square. Like this we can. Or sir, I will write in terms of cot, sir. Replace tan with 1 by cot, so it becomes cot square a minus 1 cot square a plus 1. Like this we can write the formulas. Now if you write the formula, the same formulas for cos a, because there 2a is becoming a, that means half of it, right students? Now half of it means what? Cos square a by 2 minus sine square a by 2. Next 2 cos square a by 2 minus, next 1 minus 2 sine square a by 2. Next 1 minus tan square a by 2 by 1 plus tan square a by 2. Like this we can write. Sir, still I want to simplify further, like I mean, because I know that cos 2a is equals to 2 cos square a minus 1. So I want to write the formula of cos square here, or I want to write the formula of sine square. Then what I will do? Move minus 1 to other side. Cos square a is equals to, it becomes 1 plus cos 2a. And 2 is there now, if you move, it will be by. Similarly, cos 2a is equals to, we have another formula, 1 minus 2 sine square a. So 2 sine square a, this that means sine square a is equals to 1 minus cos 2a, and if you move 2 to also it becomes by 2. Very important formulas. The questions will use these formulas like anything. Nana. For example, if you write the cos a formula also, I mean sorry, cos square a by 2, it becomes what? A is to a, that means it will be 1 plus cos a by 2. And if you write the formula for sine square a by 2, it will be 1 minus cos a by 2. And if you move square to also it will be under root like this. Okay students, this is how we can write the formulas. So then what about answer? Before going to discuss this, I will discuss, okay, first I will discuss this question, then we can discuss about tan formula. Okay. Sine 2 theta formula we know, and just now we discussed 1 plus cos theta, so I am writing separately. Similarly in denominator also sine 2 theta and plus 1 minus cos 2 theta. What is sine 2 theta, Nana? 2 sine theta cos theta. 1 plus cos theta is what? 2 cos square theta by 2 sine theta cos theta. 1 minus cos theta is 2 sine square theta. So I have 2 cos theta common in the numerator. So then I will get sine theta plus cos theta. And I have 2 sine theta common in the denominator. You can see that. So cos theta plus sine theta you will get it. So these two get cancelled, So what is the answer, Nana? Cot theta. Like this we can use the formulas definitely. Okay. Of course here directly I can see sine 2 theta cos theta, but sometimes you can't see directly. You have to understand, okay, this formula I need to use it. Okay. So anyway I have place here. Let me discuss tan 2a formula also. So what is tan of a plus b formula actually? So tan a plus tan b by 1 minus tan a tan b. Right. So I will replace b with a. So what I will get here now, tan 2a is equals to 2 tan a by 1 minus tan square a, because tan a into tan a tan square. Similarly, tan a if you write, what you will get here now, 2 tan a by 2 by 1 minus tan square a by 2. Right. Like this we can write the formulas for this. Sir, what about sin 3a, cos 3a, tan 3a, sin 3a? How we can prove it? Again, 3a, a plus 2a, sin of a plus b, and expanding it, and you can easily get it. So you can directly remember this way. So 3 sin a minus 4 sin cube a is sin 3a. Next, cos 3a, reverse. That means 4 cos cube a minus 3 cos a. Then what about tan 3a, sir? Tan 3a is 3 tan a minus tan cube a by 1 minus 3 tan square a. So these are the sin 3a cos 3a formulas. How we can prove it, Nana? Again, same way, 3a, a plus 2a. We'll use sin of a plus b to prove sin 3a. Cos of a plus b to prove cos 3a. Tan of a plus b to prove tan 3a. Like this we can prove those formulas. But anyway, it's fine, I think, because already you got till tan 2a. If you understand that pattern, similarly you can do it. Now, look at this question. So here you have 2, and there you can take 2 common, then I will get 1 plus cos 4 theta. 1 plus, so definitely we'll try to cancel the square roots. See, I have the formula for 1 plus cos 2 theta, which is 2 cos square theta, because cos 2 theta is 2 cos square theta minus 1. Then what will be formula for 1 plus cos 4 theta, Nana? 2 theta becoming theta, so 4 theta becomes 2 theta, so 2 cos square 2 theta. I will write that here. So what I will get here, under root of 2 plus under root of 2 into 2 cos square 2 theta. So which is 2 plus what, Nana? 4 cos square, which is 2 cos 2 theta. So again 2 common, I have 1 plus cos 2 theta. Again 1 plus cos theta, we have the formula which is 2 cos square theta. Now 4 cos square theta becomes what, on a cos theta. Like this we can play. Right? So if you know the formulas, we can play with it now. Definitely. Okay? Transformation. The basic. Like I'm so my point of doing this video is just I want you to be clear with the formulas and concept, like how simply you are doing the basic questions. If you are perfect in this, then if you solve some few questions, then definitely you're going to do the next level questions. Okay, I'll do that video on the next level questions also, but now I want you to be clear with the concept. Now transformations. So transformations, we have sin of a plus b formula, sin of a plus b plus sin of a minus b formula, right? What is the formula? 2 sin a cos b. Next, sin of a plus b minus sin of a minus b formula. What is the formula, Nana? 2 cos a sin b. Next, cos of a plus b plus cos of a minus b formula. What is the formula? 2 cos a cos b. Next, cos of a plus b minus cos of a minus b. So what is the formula, Nana? Minus 2 sin a sin b. Right? Now, let us take that a plus b is equals to some c and a minus b is equal to some d. Now add these two, you will get 2a, because plus b and minus b get cancelled, you get c plus d. Then a is equals to what, Nana? C plus d. Subtract both, then a get cancelled, you get 2b is equal to c minus d. Then b is equals to what, Nana? C minus d. Right? So now you can rewrite these formulas. The first formula can be written as what, Nana? Sin c plus sin d. Right? Replacing a plus b and a minus b with c and d respectively. Then 2 sin a is c plus d by 2 into cos b is c minus d by 2. Next, sin c minus sin d is equals to what, Nana? 2 cos c plus d by 2 into sin c minus d by 2. Next, cos c plus cos d. What, Nana? 2 cos c plus d by 2 into cos c minus d by 2. Next, 4 cos c minus cos d, my bad, cos d. What will you get, on a minus 2 cos, sorry, sin of c plus d by 2 and sin of c minus d. In few questions, in few books you may see that writing d minus c and minus they will cancel. It's fine, because sin of minus theta is minus sin theta. You can change it, or you can remember like this also. Anything is fine. So these are the transformations formulas which are going to be useful to solve the questions also, because if you remember, we did one question like cos 20 plus cos 80. There you can directly use cos c plus cos d formula, get the same result. Even there are like some 7-mark questions in your boards. Okay, that also you have to use this formula. 7 marks and 8 marks in AP also depends on this question, this formula only. Okay. For example, look at this. In triangle, actually this is in triangle ABC, we have to find what is cos 2a, cos 2b, cos 2c in triangle ABC. That is the question. So triangle ABC means what? A plus B plus C is equals to 180 degrees. This is like a important type of 7 marks question for boards actually. So now first if I take first two terms as cos C plus cos D. What is the formula of cos C plus cos D? 2 cos C plus D by 2 into cos C minus D by 2 plus cos 2. I can take 2 common and out, and the cos A plus B can be written as what? 180 minus C into cos of here A minus B. So now here plus cos 2c. I am not writing any formula for cos 2c because I want to see what I will get here based on this, because I have many formulas for cos. So definitely I should know like which one I have to use here, sin or cos or tan or so what. So cos of 180 minus theta, second quadrant cos is negative, so minus 2 cos C into cos of A minus B. So since I have cos C here, I will write cos 2C in terms of cos, which is 2 cos square C minus. So minus 1 plus, here I will write 2 cos C common, then I have or else let us write with minus 2 cos C only, that is better. So minus 2 cos C common, so then I have cos of A minus B minus cos C, right? So minus 1 minus 2 cos C cos of A minus B minus cos C. What is C, Nana? 180 minus of A plus B. So minus 1 minus 2 cos C cos of A minus B. 180 minus theta is what, Nana? Minus cos theta. So plus cos of A plus B. Now again you can see that cos of A plus B plus cos of A minus B, which is 2 cos A cos B. So what is your answer, Nana? Minus 1 minus this is 2 cos A cos B and this is 2 cos C. So total 4 cos A cos B cos C. This is how we can prove it. Right. Next. See here they given cos A plus B plus C is 270. Same process, in place of 180 they given 270. That's it. So A plus B plus C is equals to 270 they given. Same. So A plus B is equals to 270 minus theta you will write. Or C is equals to 270 minus of A plus B. So same process. You can just give a try about this question. Right? Next, I want to discuss one more type. For example, sometimes they may give you the question like, okay, sine square A by 2 plus sine square B by 2 plus sine square C by 2. They will ask us to do this. Is equals to what? In a triangle, for example. Now, sine square A by 2 formula. If you recall, we have this sine square in, of course, in trigonometric identity, sine square theta plus cos square theta equals to 1 we have. And where you have this sine square, if you recall, cos 2A formula. Cos A formula you'll have sine square A by 2. So we know that cos A is 1 minus 2 sine square A by 2. From this I want sine square A by 2. So I will get 1 minus cos A by 2. And this is 1 minus cos B by 2. This is 1 minus cos C by 2. So I'll get 3 by 2 and minus 1 by 2 common every time, because 1 by 2, 1 by 2, 1 by 2 is 3 by 2. In all this you have 1 by 2 common. So I have cos A plus cos B plus cos C. Now how we will solve, sir? No, 3 by 2 minus 1 by 2 is 1? No. So we can't do that. We have to leave it like this only. So cos A plus cos B plus cos C. Again, you can see cos C plus cos D formula. So 2 cos C plus D by 2 into cos C minus D by 2 plus cos C. So 3 by 2 minus 1 by 2. 2 cos A plus B is 180 because it is a triangle. I'm talking about triangle. So A plus B is 180. So 180 minus C by 2 into cos of A minus B by 2 plus cos. So now I will have 3 by 2 minus 1 by 2 into cos of 180 by 2 is 90. 90 minus C by 2 is what, Nana? Sin C by 2. And cos of A minus B by 2 plus, since I have sin here, I will write cos C in terms of sin. Cos A in terms of sin is what, Nana? 1 minus 2 sin square C by 2. So now that 1 1 by 2 into 1 by 2, so 3 by 2 minus 1 by 2, and minus 1 by 2 of this entire thing. I can take 2 sine c by 2 common to what I will have here, cos of a minus b by 2 minus sine c by 2. Sine c means 180 minus of a plus b by 2. So this is 1 minus 1 by 2 of course 2 to get cancelled. Then we have I have sine c by 2 into cos of a minus b by 2 minus sine of 90 minus theta. 180 by 2 is 90. 90 minus theta is cos theta. So cos of a plus b by 2. So I don't know, my place is not sufficient. Hope you will adjust with that. So 1 minus, it's like cos of a minus b minus cos of a plus b, which is 2 sin a sin b. So it will be 2 sin a by 2 sin b by 2 sin c by 2. So this is how we can do it now, right? Okay, so in the next video I will upload like more questions in like from, of course I'll just do separate videos like for boards 4 marks 7 marks important questions. I will do one video, and even in like in mains and Ncert I will do another video now. Okay, so thank you so much for your time. Thank you so much.